Okay, let's unpack this. We're doing a deep dive today
Hmm.
into an industrial challenge that is, well, it's often literally invisible, but it costs billions in downtime and risk.
Hmm.
It's so pervasive that the people who study it, they actually have a name for it. They call it state blindness.
And it's such a powerful term because it perfectly describes the problem.
Yeah.
You think about these massive industrial operations, manufacturing, energy, you name it, they are just packed with sensors
Data everywhere.
everywhere. We have all the data on temperature, on pressure, vibration, flow rate, but that information is often locked away in a control room, maybe 1,000 feet from the actual equipment it's describing.
Exactly. And that's why we're looking at sources today detailing a genuinely a revolutionary approach to solving this. It leverages something called spatial AI
Hmm.
through a new solution from EON Reality called EON IoT IQ.
Right.
So our mission is to really understand how this technology creates a kind of sixth sense for industrial workers, how it lets them perceive and confirm the true real-time status of critical equipment right at the point of work.
And that inability to perceive the status spatially, that is the very core of state blindness. You know the sensor exists, but you can't see what it's telling you on the machine right now. And this isn't just some minor technical glitch. This can be the difference between safe operations and, honestly, a catastrophic failure.
So if we look at the data the sources provided, the stakes are just staggeringly high.
Mm-hmm.
We're talking about risks that are completely unseen by the naked eye,
Right. An internal crack in a pipe, for example.
or an undiagnosed vibration pattern that's signaling a huge mechanical failure is imminent, or even just a sudden pressure buildup that could lead to an incident.
Yeah.
These dangers are physically present, but the sensor data alone isn't enough if a human operator has to go searching for it.
And it's crucial to understand this problem isn't about a lack of sophistication in the equipment.
No, not at all.
And it's not even necessarily a lack of knowledge in the workforce. The sources really stress this point. It's an issue of perception. It's an issue of spatial context. Workers need to know definitively, is this piece of equipment energized? Is it pressurized? Is it safe to even approach?
And that constant ambiguity,
Yes,
that's what drives massive inefficiency.
it does.
Let's talk about a specific scenario the sources bring up. Lockout tagout, or LO2.
A huge one.
Yeah, it's this vital safety procedure to make sure equipment is totally shut down and can't be started while someone's doing maintenance. State blindness makes these LO2 processes slow, complicated, and just prone to catastrophic human error.
Because how do you confirm the energy state?
Yeah.
How do you know for sure if you can't see the real-time sensor data right there on the physical breaker you're about to touch?
You can't, you're guessing.
And that human element is where the risk just crystallizes. The operator is forced to make assumptions or rely on these fragmented data points, and the efficiency cost is brutal. Well, when systems fail or need troubleshooting, the average time for a root cause diagnosis in these complex industrial systems, it can easily take hours. Hours. And think about the value of that downtime when you're talking about a chemical plant or a power grid. That's hours of lost production just because someone couldn't find an invisible pressure reading where they actually needed it.
And the safety picture is even darker. The sources provide some hard metrics here that really make you sit up and pay attention.
They do.
When you analyze safety incidents, between 30 and 50%, that's a huge range. But between 30 and 50% of all safety-related delays or incidents are tied back to state misinterpretation.
Someone thought the machine was safe. Someone thought the line was depressurized.
Someone just misinterpreted an abstract data point on a screen far away.
And that inability to visually confirm these unseen risks contributes to literally thousands of global industrial safety incidents every single year. So when we talk about state blindness, we're really talking about a fundamental breakdown. It's a breakdown in the interface between abstract digital information and concrete physical reality, a breakdown that costs lives and billions in operational delay.
So the necessity for a solution is just, it's overwhelming. But here's the puzzle, right? The industry has invested massive amounts in control systems. They have SCADA systems, HMI panels, CMMS tools.
Yeah, these huge industrial brain trusts.
Exactly. Yet they haven't fixed state blindness. So why do these existing sophisticated solutions fall so short?
They fall short because they create a cognitive bottleneck. Right now, workers compensate by battling what the sources accurately call fragmentary insights.
Okay, what does that look like in practice?
Think about the workflow. A worker on the factory floor sees a symptom, maybe some smoke, maybe a strange noise. To diagnose it, they have to physically walk to a local gauge, which might be old or hard to read. Then they have to walk maybe all the way to the central control room to check an abstract HMI dashboard. Then they might have to pull up the computerized maintenance management system, the CMMS, to see the repair history.
It's like checking the pulse of a massive building by reading its tax returns.
That's a great way to put it.
The information is technically there, but it's completely detached from the physical location of the patient.
Precisely. Take SCADA systems. They are fantastic for overall process control, for data aggregation. They give you the company's annual report, they tell you the general health and trends.
But they can't tell you which specific bolt on which specific turbine is vibrating loose right now.
Exactly. They excel in specific functions, but they utterly fail to provide that spatially contextual real-time visibility.
Here's where it gets really interesting. The fundamental failure here is that these systems force the human operator into this crippling task that the sources call mental mapping.
And that's the absolute core of the challenge. The operator is forced to look at a number, say 140 psi, on a screen in a cool, quiet room, and then mentally link that number across potentially hundreds of feet of piping and machinery to the exact valve it represents in a loud, hot operational zone.
And that process of manually translating disjointed abstract data into a physical reality, that's a huge cognitive challenge.
Huge. And in an emergency or when systems get really complicated, that mental map just breaks down. It leads to delays, bad decisions, and real risks.
So that's the key pivot. If the mental gymnastics are the bottleneck, the solution can't just be more data.
No.
It has to be better delivery of that data. So what is EON IoT IQ doing differently?
It fundamentally changes the environment by introducing spatial AI and spatial anchoring. Instead of forcing the operator to go to the data is brought to the physical object. EON IoT IQ takes all that complex, invisible data, the vibration levels, the temperature, the flow rate, RPM, energy states, and it integrates it directly into immersive 3D or augmented reality environments.
So just to be clear, if I am standing next to a massive centrifugal pump and I'm looking through an AR headset or even just a tablet, the system doesn't just show me some generalized dashboard. It overlays the pump's internal state directly onto the pump itself.
That's exactly right. The platform closes that gap between the real-world equipment and its digital twin, its digital representation, instantly. This spatial anchoring is the key mechanism. It uses the physical location of the machine to determine what data stream to show you.
So the information isn't abstract numbers anymore?
No, it's a visual state that is physically tied to the asset. This provides that immediate, that aha moment of comprehension that just eliminates the cognitive overload.
I can see how that radically cuts down on diagnosis time.
Yeah.
Instead of tracking all the way back to the control room, you just look at the equipment and you immediately understand its health.
Instantly.
Let's dive into the specifics of how they do that. How do they deliver this instant comprehension? It can't just be raw numbers floating around in midair.
No, it's highly curated. It's very intuitive. The platform uses visual coding that's derived from the raw sensor data. The goal is to provide status classifications and alerts that are instantly recognizable.
We're talking about, like, the simplest visual codes.
The simplest: green for normal, amber for warning, red for critical.
So instead of needing to remember that, 85 degrees Celsius is the danger threshold for this one particular component, you just see a universal warning sign, a color.
Absolutely. The system automatically classifies the raw numbers, and it uses something called anomaly highlighting. So if a bearing is vibrating outside of its acceptable range, the bearing housing in your AR view might start glowing red or pulsating. It does whatever it needs to do to ensure that critical state demands your immediate and full attention.
Tell us more about those visual effects, the real-time sensor overlays and the spatial anchoring effects. How does the system visualize all that complexity without just causing more visual noise?
It uses some really smart visual mechanisms. So you might see holographic panels that float right next to a valve, displaying live flow rate and pressure gauges.
Okay.
Or, more dramatically, you get these equipment glow effects that use color and animation to communicate the state. So, for example, if a pipe is running hot, the pipe itself glows orange or red in the AR view. It visually communicates heat transfer, even though a worker can't physically see an infrared signature.
This sounds incredibly effective for maintenance, but I have to imagine the potential for training it's profound, especially for new technicians who need to grasp the invisible physics of these complex systems.
Oh, that's one of the most powerful applications for sure. EON IoT IQ integrates immersive training where they use these scenario-driven demonstrations.
So what would that look like?
Imagine teaching a new hire how a closed valve leads to pressure buildup. In a safe virtual environment, they can look through their device at a 3D model of a system. They can virtually close the valve and instantly watch the pressure gauge needle
Yeah,
spike,
they'd see the flow visualization stop.
see it stop, and then they'd observe the pipe itself turn red due to stress, all in a simulation.
That's a massive leap forward. It's bridging theoretical knowledge, what you read in a manual, with the practical, visually grounded understanding. And it does it so much faster and safer than traditional methods.
It creates a kind of muscle memory for anomaly recognition. They learn the cause and effect relationship, the invisible physics of their job, without ever risking real-world equipment or, more importantly, their own safety. It prepares the workforce for proactive maintenance, ensuring they don't just react to failures, but they anticipate them by understanding these visually coded warnings.
This technology sounds like a complete paradigm shift, but, historically, massive industrial infrastructure updates are slow and incredibly expensive.
They are.
What did the sources say about deployment flexibility? Is this a rip and replace kind of solution?
No, and that's where the design philosophy really shines. The system is built for seamless deployment. The sources emphasize that industries can implement it flexibly.
So you don't have to do it all at once.
Not at all. It can range from full, standalone, immersive environments to integration with your existing control systems. They even specifically mention starting with an MVP, a minimum viable product.
Okay, so that means they can quickly demonstrate the value using digital twins and simulated data even before hooking up every single piece of physical hardware.
Exactly. It significantly lowers the bar for adoption. Instead of a multi-year overhaul, they can prove the concept and then integrate piece by piece.
It also reflects a much more modern approach to equipment management.
It does. The platform treats every piece of equipment as what the sources call a stateful entity.
What does that mean?
It's essentially a living system that is constantly reporting its health. This allows for predictive and proactive maintenance strategies rather than just reactive fixing. It shifts maintenance from a scheduled hassle to an informed, necessary intervention.
Speaking of informed intervention, the chairman of EON Reality, Dan Ladroskar, he summarized this whole movement perfectly. He viewed this solution as, and I'm quoting here, the gold standard of machine intelligence made practical today.
That's a great quote.
It is, because he adds that it empowers the people at the core of industrial innovation by helping them see what was once invisible.
And that quote just drives home the transformation. It recognizes that the ultimate goal of all this machine intelligence, it isn't to replace human workers, it's to give them superpowers.
The ability to see the invisible.
The ability to act decisively because they are receiving spatially relevant, immediately digestible information. It transforms passively collected big data into actively anchored intelligence.
That leads to an interesting question, though. You mentioned the quick transition to these visual codes. If workers are trained to trust the green, amber, red visual signals, how quickly can a traditional technician actually switch from reading detailed HMI values to relying purely on an AR overlay?
That's a great point.
Is there a learning curve or maybe even a psychological barrier the sources address?
There is, and the training integration is the key to addressing it. While there's always a period of adjustment, the system's focus on that immersive, scenario-driven training is really designed to accelerate that trust.
So they learn to trust it in the simulation first.
Exactly. By training workers in a safe, virtual environment, they learn that the visual code, that red glow, is directly and reliably correlated with a specific, measurable fault state in the underlying sensor data. They trust it because they've seen the cause and effect demonstrated visually and safely long before they have to rely on it in a high-pressure, real-world troubleshooting scenario.
So what does this all mean for us? Whether we work in industrial ops or just trying to understand how the world of data is changing.
It means that EON IoT IQ is transforming operational efficiency and safety by giving industrial workers a necessary upgrade. It's a visual, instantaneous understanding of these complex, invisible systems. This proactive approach, where you can instantly perceive the state of critical assets, is rapidly becoming the new standard for industrial performance.
So the ability to understand these deep hidden systems quickly is becoming the baseline for being well-informed in any data-intensive field. The core insight here, really, is that data is only valuable when it's delivered in a way that respects human perception. And if spatial AI can fundamentally eliminate state blindness for massive hidden industrial machinery by spatially anchoring that data, we have to ask a bigger question. What other hidden, invisible processes in biology, in finance, maybe in complex logistics systems, are we currently failing to perceive?
Right, what are we missing?
What critical insights are we missing just because the data is abstract and we are still being forced to manually, mentally map all this complex information? That's a provocative thought for the next time you look at a dashboard.